There's a saying in my mother tongue that goes like this: van sit en staan is lê die lekkerste. And that roughly means between sitting and standing, lying down is the nicest. Now if you do too much of that, nothing ever happens. So I have been doing quite a lot already. So welcome back to the shop, you oaks. If you don't know me, my name is Diff, as in differential or difficult, except I'm neither of those. And I'm working on a Renobug project for my wife. If you're not familiar with it, it's a 1959 Renault 4 CV body that is now permanently mounted onto a 1971 Beetle floor pan that's been shortened and quite modified. And one of the big motivations for me to make progress on this project is that it ensures that I get good suppers every night. So anyway, let me show you what I've been busy with. I finally got the little dashboard painted, all nice and shiny. Not really my style, but it makes Gaga happy. So who am I to argue? Yes, Gaga is what my grandson calls my wife. Now I'm happy this is done, because once this is fitted, I can fit the steering column, which gets us one step closer to driving this little noisy car. And just look at this, wires everywhere. Yeah, I've been spending many hours in here already doing the wiring, because I figured it would be just easier to do this before I put a little dashboard in place. So let's see if we can make a little sense from this chaos. Right here, starting on this side, that's the fuse holder that I salvaged from my donor Beetle. You might remember from a previous video when I made this bracket, and that's one there as well. And then moving on, these wires will be for my little ref counter or tack. I've already wired in a headlight switch. This one here is the emergency flashes or hazards as we call them. And down here now we've got, starting from that side, this is the original Beetle 5-point headlight relay. There's my flasher unit, 4-point relay for my starter solenoid, 4-point relay for future spotlights, and this right here is my main fuses. I'll show you more about that just now. This bunch of wires, that will go to my Beetle speedometer, and all the little lights and warning lights and everything else that's part of it. And then this bunch right here, that will connect to my steering column, also the original Beetle steering column with the dipper switch built in, also the turn signals or indicators, all of that, and of course the starter switch. Before we do anything else, let's quickly talk about fuses. That little thingy right there, because I find that many people do not really understand what their job is. So in simple terms, a fuse is a safety device to protect an electrical circuit. Now remember that, to protect an electrical circuit, which is exactly with what we've got here. We've got a battery, here in our positive line we have a fuse, a switch, and a lamp, which is our load or our consumer. When we close the circuit by turning on the switch, the lamp burns and we've got current flowing through this wire, these wires. The amount of current that's flowing at the moment is determined by our consumer or our load right here. Let's measure it. You can see right here we've got about 1.5 amps of current flowing with our lamp burning. So the fuse needs to protect the circuit against high current. And when a current flows that's higher than the rating of the fuse, it will blow. So we just measured that our load here, or our device, requires 1.5 amps. So obviously our fuse can't be less than that, because then it will immediately blow. So what size do you reckon the fuse would need to be in this case? well, I suppose at least 2 amps or maybe 5 amps. So in what instance would we get a higher current than normal? Could be when there's a fault in the device, in a lamp, in a load, or could be there's a short circuit somewhere in the wires, insulation is worn off, and it's causing a short circuit where, for instance, the positive could touch against the frame of the car. So the fuse has got 2 jobs. It needs to protect against a service overload here or a short circuit. So this little circuit here might look just fine, but it's actually a disaster, and it's got the potential to burn down the car. Why am I saying that? This yellow fellow right here, that's the first big problem. It's a 60 amp fuse, and that means it will only blow when the current flow exceeds 60 amps. Okay, so what? Well, the other big problem is this cable right here. That's a 1mm cable, and a 1mm cable is rated to only carry in a region of about 10 to 15 amps. When more than that starts going through that cable, we exceed that rating. What happens? The cable starts heating up, the insulation melts, fuse is not blowing yet because it can handle 60 amps. And when all this starts happening, heating up, the melting, what's the result? Yes, we get a dead short to the chassis or the frame of the car, sparks, flames, big tears. Bad, bad, bad scenario. Remember what I said? The job of the fuse is to protect the circuit. So you can see now that there's a huge relationship between the fuse size and the wire size. And the first job of the fuse is actually to protect the wire. This hefty fellow right here would be the correct cable for a 60 amp fuse. 16 square millimeters, or for my American friends, AWG 5. Jeez, I know that was a mouthful, eh? So if you're still here, you deserve a beer. To cut a long story short, just go ask Professor Google about the current carrying capacity of cable and ensure that it exceeds your fuse rating. Oh, and by the way, the pro electricians, don't nail my ass to the floor. I know current carrying capacity depends on many factors, but we're just talking about the basics here. So this right here, that's not the way the Beetle is normally wired, or many other cars for that matter, but I like to do it this way. I call it my main fuses. And to explain it now, this red one there, that's a 50 amp fuse. Top side of it is connected directly to battery / alternator. And then on the bottom end, we go out and we move on to the starter switch, ignition. And the other one is for my solenoid relay. The fuse holder I found has got 2 positions for fuses, so I thought, why not use the other one? So I've jumped it in the top there. And on the bottom side, we move on to the fuse box. So this point is always live, and that will supply items like radio, brake lights, horn, and so on. Here's a schematic of my main fuse installation. So if you'll indulge me, I'll quickly explain it to you. We come from the battery positive in the back of the car with a nice thick cable that can handle the current all the way to the front under the dashboard where my main fuses are sitting, right there. Like I said earlier, the cable is relative to the fuse size, so the cable will be able to handle the current that the fuse can handle. Under this fuse, we move on to ignition switch. So in the ignition switch schematic on this side, this is when I switch ignition on. We close there, and power flows through to my fuse box part where we have ignition switched things. The other side of my ignition switch would be the starter side of it. So when I turn the key to start the car, we close that contactor and power can go through to the starter solenoid. This main fuse right here supplies power to the fuse box part where we have the always hot things. Now in my case, I've put the horn there, the radio, what else? My brake lights as well. Yeah, I suppose it's your choice what you would like to be on this side. I know on some cars they also connect our headlights here. I did not do that. So my headlights can only work when ignition is switched on. It depends on different cars, it varies. So in a way it just requires a bit of common sense what you would like to have on this side. On a side note, the Beetle starter switch, ignition switch does not have an ACC, so there is no ACC option in this setup. So I did not buy this wiring harness from anyone. I made it up from scratch using salvaged pieces of wire. So many of this wire I took out of my donor Beetle, and it's actually not as difficult as you think to do it from scratch. I might give you some pointers just now. For the start, maybe let me just show you where these wires came from. The source of all my wire, I stripped the wiring harnesses out of the old donor cars and then I pick them apart as required. Why buy if I can salvage? Yeah, old Duffy is such a miser. Well then, I think I've got all that wiring in there waxed. So it's time to put the freshly dashboard into place. And you can see what that looks like. Got a few bolts to tighten in here. So before I tighten it up, I'm going to put in this piece of, what do you call this stuff? Fender weld, I think. It'll needs to go in there, something like that. So we don't have a metal to metal fit here. I'm just going to fiddle with this a little bit and get it in nicely in place.
1 hour later.
It's starting to come together. I got my little dashboard bolted into place. I've already got that Beetle Speedo and the switches fitted. So now I'm going to get my steering column into place. Now the steering column is also salvaged from my donor Beetle. I just clean it up a little bit. I also tested the switch here, make sure that all works. So let's just get some bolts in here so we can get this fellow mounted. So once I've got this bracket tightened up, I can do some final adjustment because this whole steering column can slide forward and after a little bit. It's got some slots here, so we can then do the final tuning to make sure that it sits exactly where we want it. Alright, so I've got this. That'll do. Now let's adjust this a little bit. Takes an Allen key in here, and then you can adjust it by sliding it in and out, or forward and aft, depending on how you look at it. Now I can join up all these wires. This lot here, that comes from my ignition starter switch, and this bunch, that goes to the flasher indicator lever switch and headlight dim and bright. And I've got to connect them to this bunch, which goes to my wiring harness that I've already installed. So we've got some joining up to do here and cleaning it up to make it look nice. Alright, let's get some solder on here. I've heard some guys say solder. So how do you say it? Solder or solder? There we go. Right, now I can put over my heat shrink and we'll just shrink that into place, and then I like to do it double on some wires, so I'm going to put another piece over here If we can get some assistance here, thank you, sir. What is going on here now? There we go. Okay. Now, of course, one could use these male-female type of connectors to join the wires, but I prefer a more permanent connection. I mean, it's not like I'm planning to remove my steering column again anytime soon. So this is how I do it. I strip the insulation back a little bit and then just open up the strands, and then I just push them into each other like this. And then I take a couple of strands from an off-cut piece of wire and I wrap it nicely like that. Some solder. There you go. And that is cooled down. Slide over our heat shrink. A little bit of heat here from my big lighter to shrink it into place. Yeah, and sometimes I might even fit 2 pieces of heat shrink if I feel I need more insulation. And now I have a nice and secure connection. No chance of corrosion or possibly coming apart. One less thing to worry about. Well, whilst we are at the bench, let's quickly talk about these crappy connectors that I don't like at all. When you crimp them through that hard plastic sleeving, that crimp is always suspect. And how many times have I seen this? That even after crimping, if you pull hard enough, you pull that connector right off. Not good at all. Look at this crimper here. That's the one type they sell you to use with these. Look, it's even got fancy little colored dots and all. But look at this. If you look carefully there, the crimper actually just squashes the thing flat. There's no mechanical strength in that whatsoever. So, since 90% of electrical problems are due to bad connections, and since those are the only type of connectors I can find at my local auto parts store, this is what I do. I pull off that piece of hard plastic with needle nose pliers, which leaves me with just the metal piece, which I can now solder onto the end of my wire to get a positive connection that I never have to worry about. Follow that up with a little piece of heat shrink, and it's as good as it gets, man. And in my opinion also looks a lot more professional than having blobs of multicolored plastic all over the show. Back on the Renobug, I've got some sleeving and a few cable ties to tidy it up, and my electrical connections are done. Okay, now I can fit my custom, one-of-a-kind Yellowwood steering wheel. Let's tighten that up and fit the center cap. There we go. Yes, we finally have steering. Whoopee! Got the other end of my steering shaft connected. New rag joint, new bolts. Thanks, Mesco Engineering Supplies. Everything is tight and good. So now I can fit my cover that goes like that. And now if I turn this round thing, that round thing moves. And that's exactly what we want. Okay, so with all my wires connected and my fuses in place, let's make the system live by connecting the positive here. And I didn't see any sparks or any smoke. So far so good. Because if I were to see a spark here, that would mean something is consuming electricity. And that's not something we want at this point of the game. Next I'm going to switch on ignition, and then I should see the generator light and the oil light. Let's see. Ignition on. Well, my generator light is burning, but I don't see any oil pressure warning light. Now why would that be? I'm going to have to do some troubleshooting. Let's switch this off first. I found the problem. When I take the wire that goes to the oil pressure warning light and I touch it to ground or connect it to earth or negative. Yes, if I touch it to earth, the oil pressure light comes on. So that means the oil pressure switch is faulty and I'll have to replace it. Okay, so that explains that. Let's see if our starter switch works. Haha, awesome. One more time. Fantastic. Let's try something else. Both my cigarette lighter and hazards or emergency flashes, as you guys in the States call them, are permanently hot. So I don't need the ignition switched on for them. Let's test it and see if it works. Yes sir, that works. Let's check the hazards. Aha! Yeah, so these cool little lights are the only turn signals I have at the moment. They were like this on the original Renault. And I thought, hey, it'd be cool to get them to work again. So yeah, I haven't got any taillights or headlights connected yet. But yeah, these ones are doing their job just fine. It works, it's not working, it works, it's not working. Up front here, I've got the wires in place for the headlights, but yeah, still got to mount fenders. So that still needs to be done. Same dealio here in the back. I've already got brake light, tail light, and my two turn signals or indicator wires. But yeah, I've got to fit the back fenders and the tail lights before I can go any further with this. Yeah, so nothing else to test at this stage of the game. Oh, the fuel gauge did show some movement, but there's very little petrol in the tank, so it hardly moves. But it is working. Yeah, so everything else, horn and wiper, I still got to sort out the wiper motor and all that. That's going to be another little challenge. And then taillights, headlights, still needs to be done. But I feel we are making good progress. We've got steering, electrics are in place, car starts, got some stuff working already. So I'm happy. Hopefully you as well. Thanks for hanging out with me out here in my forest workshop. I enjoyed your company. So I'll see you in the next video. As always, have a lucky one, my brothers and sisters.
Whatever makes you happy, it just depends on